Alright, in this lesson we're going to take a look and remind ourselves about what a logarithm really represents and how to calculate some of these in our head. And then we're going to jump to the ones that we can't calculate in our head, that we need some sort of systematic way to approach it on a calculator to make this work out for us. Ones that come out to be answers that nobody should ever know mentally. So let's first refresh our memory on something. Let's start with something easy. For example, this one right down here. What this is saying is 4 to the what power equals 4. So we know that 4 to the first power equals 4. So this entire logarithm right here represents 1. And now if we take that approach over here, 4 to the what power equals 1. Well, anything to the 0 power equals 1. How about 4 to the what power equals 16? Well, that would be 4 squared, so 4 to the 2. Over here, we have some fractions. Let's remind ourselves now. 4 to the what power equals 1/4? Well, that's going to be -1. Remember, a negative exponent means we really have a reciprocal. So we flip it to make it positive. 4 to the what power equals 1/16? Well, that's kind of like this one down here, but it's going to have to be a -2 for an exponent. So these are some examples of ones we could actually analyze in our head and figure out. Now, what we're going to get into over on this other side here are ones that you wouldn't normally be able to do that with. For example, log base 4 of 11. Now let's remember what that means. That means 4 to the what power equals 11. Well, that's not a nice whole number. It's not something you should absolutely have memorized. Okay, nobody really knows these ones, but you can estimate it a little bit. Okay, it's one of those things we're going to have to either look up in a table or get the calculator to do. So if I look down here, well, 11 is somewhere between 16 and 4. So my exponent is going to be somewhere between 1 and 2. It's 1 point something, but I don't know what that is. So if I'm going to use a calculator to figure this out, I can't just type in log 11. And the reason I can't do that is if my calculators, most of them, now not all of them, most of them are programmed with a base of 10. So if I type in log 11, it's asking me 10 to the what power is 11, and I'm not looking for that. So the only way to get around this is what we call the change of base formula. You're going to find this very useful. You're going to have to use it several times. And the change of base formula basically says I can take log 11 and divide it by log 4. Okay? Now notice, I didn't write a base in there, so it really means base of 10. Base of 10. Okay, if I can use any logarithm I want, and as long as I use the same base for this number as I do for this number, the ratio of these, when I divide them, will give me the exponent I'm looking for over here. So I don't happen to have a calculator with me at the moment, but you could easily take log 11, type it in your calculator, get a decimal, divide it by log 4, that decimal, and you got your answer. Now you could use your log button, or you can use a button that a lot of people forget about, the natural log. Okay, natural log 11, that's just got a base of 2.718, a base of e. And I can use natural log of 4. That's still going to give me the same thing as this one. So you try typing those in your calculator, whatever function button you have that happens to have a log or a natural log, and see what value you get. And then you can always check it by taking 4 to that number, whatever you get for this result, whatever decimal that is, take 4 to that value, and you should get 11 as your answer. So that's what we call the change of base formula.